All right, here's a second example. So we went over this yesterday in class, but people asked to see another example. So here you want to graph f, and f now is being defined as g minus h. And we're given g and we're given h. And g and h happen to be two trig functions, so we're just going to find the 5 key points for both of these trig functions. Starting with g. G has a period of pi. So here are the 5 key points. Starting with 0, there's no phase shift. So starting with 0, ending at pi, that would be 1 full cycle. Your halfway value, your quarter of the way, your 3/4 of the way, and you could just plug this into your calculator, plug these x values into your calculator to find these y values. But these are all special angles, so we should know these from the unit circle. And then move on to h. H is the cosine of x plus 2. Now that has a period of 2 pi. So now I need to go back and kind of adjust my input values. I don't want to go from just 0 to pi. That would only be half of a cycle. I want to go all the way to 2 pi. So I do go all the way to 2 pi, but I have to remember with g, I want to generate the 5 key points. So unfortunately with g, I would do 2 sets of the 5 key points. 1 cycle right here from 0 to pi, and then a second cycle from pi to 2 pi. So that's how I can get all of these points. I've got 9 of them. And then I do the same thing with these x values. I plug them into h to find the y values, and I get these. Some of these we can know from the unit circle, others, well, they're all from the unit circle, they're all special angles. These are rad 2/2, and so we just put them into a decimal. Now I've got 9 ordered pairs for g and 9 ordered pairs for h. So if I just subtract g and h, I will have 9 ordered pairs for f. And that's what I'm going to do. When x is 0, f will produce whatever 0 minus 3 is. So -3. So that's 1 ordered pair, 0, -3. When x is pi over 4, f is going to produce whatever 1 minus 2.7 is. So -1.7. And I just keep on going down the line until I get 9 y values for f. So I get 9 x values for f, 9 matched up with 9 y values for f, which means I've got 9 ordered pairs for f. And that's going to help me graph this thing. So I'm going to graph them. Let's see. Why is this not showing up? Come on. Dude. Sorry. Here you go. Sorry about technical difficulties there. So we found 9 order pairs, and I let Desmos do all the plotting. But we can plot this. Here are those ordered pairs. And to set up my x-axis, I would maybe make the everything a pi over 4. Every vertical line a pi over 4, so that'd be easier for me to graph. Now this doesn't look like there's too much of a pattern here, but there is. This is f. Please, so this is a g minus h. Please notice that h is in parentheses. If that weren't the case, it wouldn't be correct because you're subtracting the entirety of h, and h is composed of 2 parts. So you got to group them together with parentheses. And when you graph them, you can see it goes right through it. So it's it resembles some sort of sine or cosine wave, but it's definitely different in its composition of two trig functions. But we found those correct order pairs. I go right through them.